Hello, and welcome to Tech Cubicle on SAP. In this multi-part video series, I'm going to show a complete end-to-end demonstration of the power of Ansible Playbooks for SAP, the free open source automation capabilities brought to you by the SAP Linux Labs community. Follow me through the process of building a working SAP NetWeaver ABAP system running on the SAP ASE database, all hosted in the Microsoft Azure public cloud. And don't worry, you will see that the type of system could easily be SAP S/4HANA. The same steps will apply with almost exactly the same inputs. In part 1, I take you through what Ansible is. Then I touch on the capabilities of the Ansible Playbooks for SAP. I will walk you through the high-level SAP System Design, and then step by step I take you through the design of the Azure infrastructure that we will be implementing to host our new system. I discuss our method of deployment, the requirements, the components, how they will interact with each other, and even propose alternative methods that could be used. After too much talking about the design, I'll begin the technical demonstration. I will start with nothing, a literal blank Azure subscription account, and then together we will deploy the Azure resources. In the second part, we will build onto our Azure infrastructure. We flow through the setup and execution of Ansible Playbooks for SAP, which will deploy our SAP system. In the third part, I will look at how I can 100% automate the entire build process, including the Azure infrastructure build, with zero clicking from end to end. Okay, not zero clicking really, but minimal clicking and a repeatable process. As you will see along the way, nothing is guaranteed, even with infrastructure as code or IAC, but at least we can minimize errors. You don't need to be technical to understand what we will be going through, because I will be explaining as much as I can in terms that I hope will bring clarity to the world of automating SAP operations with Ansible. Apart from using the Ansible Playbooks for SAP, I will not be obfuscating the process with any scripts or here's one I made earlier items until we get to part 3. Everything will be created in the demonstrations using what I call ClickOps. That means I'm clicking around and not just running a script, so you will see what I'm actually doing. There are downsides to this approach, but I feel it's a good way of learning if you are not a command line king. In part 3, I will walk you through the code to automate the entire process. What is Ansible? At a basic level, Ansible is an agentless, scalable tool that can be used for automating and executing various tasks across large server estates using code. Because it is a generic tool, it is often used to help in the following: software provisioning. Ansible can set up and configure software on target systems. Configuration management. It ensures consistent configuration across multiple machines. Application deployment. Ansible simplifies deploying applications and services. It's really very versatile. Unlike some other configuration management tools, Ansible uses an agentless architecture. This means that Ansible software doesn't need to be installed or running on the target nodes. Instead, it relies on temporary remote connections via SSH or Windows Remote Management for PowerShell execution. The Ansible control node runs on Unix-like systems, including Windows with Windows Subsystem for Linux. The inventory is stored in plain text files and defines the target node machines. The tasks that Ansible executes are described in a human-readable language called YAML and grouped into something called playbooks. It has a modular design with many different modules and plugins for many different use cases. It has power through simplicity. In this demonstration, we will be using Ansible to execute some free open-source Ansible playbooks, groups of tasks, that will build an SAP system. The playbooks have been created and tested by a group of skilled developers. The playbooks are called Ansible Playbooks for SAP and are written 100% in YAML. You can see the playbooks, read the code, check out, fork, feedback, and contribute, because they are stored on GitHub, the internet-hosted code management tool. I've put all the links that I've used to create this demonstration in the description down below. What are Ansible Playbooks for SAP? Ansible Playbooks for SAP is a collection of open-source Apache License 2.0 Ansible Playbooks, providing common SAP deployment scenarios. The playbooks include configuration and code in YAML files, which are used as templates to deploy infrastructure such as virtual machines. This is known as infrastructure as code. The Ansible Playbooks for SAP is reusable and offers an opportunity for automated deployments using existing cloud provider and SAP APIs. The Ansible Playbooks for SAP can deploy a set of predefined SAP system scenarios onto a number of different platforms. As an example, if we look at the grid on the documentation page, we can see the list of scenarios. We see the type of system, the database, and the supported operating system. One thing to note, high availability is not an easy thing to set up and test when doing it manually. Even more complex, writing automation that would work across different platforms. That is why these scenarios are really more recommended to more simplistic use cases such as non-production or even Sandbox. There is nothing stopping you deploying a production system and then modifying it to add high availability, or even coding capability into the playbooks yourself to deploy high availability, but that will depend on your skill level. The playbooks can be used in 3 different modes. They can be used to call Terraform from Ansible, using Terraform templates to first deploy a new set of infrastructure in, for example, Microsoft Azure. Then, once the infrastructure is deployed, Ansible would deploy SAP on brand new virtual machines into the new infrastructure. Alternatively, they can be used purely as Ansible to first create new virtual machines in an existing infrastructure and then deploy SAP onto the new virtual machine. The final mode is to deploy SAP onto an existing virtual machine that already exists in an existing infrastructure. As well as deploying different scenarios to different platforms and in different modes, the playbooks also support different deployment methods. As an example, I have chosen to demonstrate using no front-end development tools such as VS Code, and I will not be using Azure DevOps. I will not be using Terraform, especially since the recent license change of Terraform, taking it towards a more proprietary closed-source product. The playbooks have been written to allow deployment execution from a laptop running Windows and using Windows Subsystem for Linux. Or, alternatively, you can deploy from a Linux virtual machine running on your laptop. Or you could even deploy direct from a Linux on your laptop. The playbooks can also be executed from Azure DevOps, but this would obviously require a DevOps account and additional setup. I have chosen to deploy using a very pure and generic Ansible-only method, which offers flexibility if you are not running on Azure or not able to install the tools onto your laptop. In the demonstration, I will be setting up a virtual machine in Azure on which I will run Ansible. This offers a platform on which a general SAP automation capability could be deployed. It's effectively a lowest common denominator setup. Lastly, the playbooks have been designed to allow prompts for those that wish to interact and input the required variable values at execution time. You need to be aware that this interactive mode is not fully supported for all scenarios at the version I'm using. It will improve over time, but for now I will use, and I recommend you use, the non-interactive method of execution. This means we adjust 2 configuration files and change the variable values ourselves before execution. You will see what I mean later in the demo. Let's take a look at the SAP system we will be deploying. The high-level SAP System Design. The SAP system I have chosen to deploy is a basic SAP NetWeaver 752 Support Package Stack 0 ABAP system. This is completely adjustable. For example, I could easily add a support package stack, but for this demonstration it really makes no difference. This system will be a single system, no high availability, with an ABAP Central Services or ASCS instance with instance number 00 and a dialog instance or PAS with instance number 01. It will be running on an SAP ASE, which is Adaptive Server Enterprise 16.0 SP4 database, which will be deployed onto the same server. All of the SAP system will be deployed onto a newly installed SUSE Linux Enterprise Server for SAP 15 SP5 as a virtual machine in Microsoft Azure. At the end of the demonstration, it would be possible to log into the SAP system using SAP GUI, although I don't go that far. Our Azure Infrastructure Design. Here we have our Azure subscription. In Azure, a subscription is a contractual agreement. It's kind of like your Netflix account. You could have more than one if you really wanted. As mentioned in the demonstration, I will be executing Ansible and the Ansible playbooks for SAP from a dedicated virtual machine in Azure. We will pre-create this virtual machine in its own segregated virtual network, since this will allow us and you to run through as many deployment scenarios as you like without the risk of accidentally removing your Ansible VM. We will host Ansible on a small virtual machine with only 1 vCPU and 1 GB of RAM, and it will run Ubuntu Linux. In Azure, we can choose a B1 sized virtual machine for this purpose. The Ansible VM is also going to be our bastion, which is just a way of getting secure access into a landscape. We will expose the SSH port to the internet and access the VM from a laptop using an SSH client. I could use a no-cost Azure Developer Bastion to provide access, but one of the things I miss in the Bastion is the colors, especially when working with Ansible. Still, I would advise you to consider using Bastion as it is a much more secure option. Our target SAP system will be deployed onto a newly created virtual machine in a separate network to the Ansible VM. The network will be pre-created by us before we execute any Ansible. If we were to use the Ansible plus Terraform template option of Ansible Playbooks for SAP, then it could pre-create the virtual network target also. The virtual machine size I have chosen will be a small D2S, which in Azure is a 2 vCPU 8GB virtual machine with support for attaching 4 data disks. And it's important to note this, as we will see in our Ansible configuration templates later. I did not want to deploy HANA because I'm doing all of this deployment at zero cost to me. That's right, zero cost.
Nice.
I registered for an Azure trial account which gives 200 USD of credit to spend over 30 days. And when I last checked, I had around 150 USD remaining. If we look briefly at the Azure price calculator, we can see that the compute cost of a small D2S V5 VM, that excludes the cost of the data disks. I'm hosting all of this in the UK South region, and if you're not sure what a region is, it is simply a geographical hosting location. In the UK we have 2 Azure regions, UK South and UK West. The UK South is in the southeast, not far from London, which is about 90 miles or 144 kilometres from where I am here. To allow network traffic to flow between our 2 dedicated networks, we will set up virtual network peering. Without peering, the network traffic would not get from our Ansible virtual machine into its own virtual network to our SAP virtual machine in a different virtual network. Each virtual machine will have a single network interface card, or NIC, with a private IP address assigned. A private IP address is only addressable on our dedicated internal network that we create. Our Ansible VM will also have a public IP address assigned to allow us to connect directly to it over the internet from a laptop outside of the Azure network. Network security is applied using network security groups, which will be assigned one on each subnet. At deployment time, the only thing we need to change in the network security groups is to allow port 22 inbound into the Ansible VM. A subnet is just a way of dividing up a network into more manageable chunks. If we compare a virtual network to be like a city, then the subnet is like a sector of a city and an IP address is like a building number. In our case, we will only have one subnet for each virtual network and give it the whole addressable range of possible IP addresses in the respective virtual networks. Our virtual networks will each have a range of 254 hosts. Except in Azure, some of the IP addresses are reserved by Azure from the range, so we don't get the full 254, but this demonstration, we won't even need 10, let alone 254. Some other resources we need to deploy in our Azure subscription are NAT gateways. Network address translation allows us to have outbound internet access from our 2 new virtual machines. From the Ansible VM, we will need to be downloading the Ansible software and importing Ansible Playbooks for SAP. From the SAP VM, Ansible Playbooks for SAP will be downloading the SAP installation media from the SAP Download Center. Without the NAT gateways, we would not be able to do this. In actual fact, you probably would, but the rules are changing in Azure and at some point that access will be denied. The Ansible Playbooks for SAP currently requires DNS for addressing the new SAP virtual machine that it will build. The DNS will allow Ansible to map an IP address to a host name. So, we will pre-deploy an Azure private DNS zone, but it must exist in the same resource group as the new target SAP virtual machine. In Azure, a resource group is simply a metadata item which anchors a resource or groups of resources to a specific subscription and region. It's simply a basket into which we will pre-deploy the target virtual network, subnet, DNS private zone, NAT gateway, and eventually the SAP VM will also be built there. Over on the right and outside of the networking requirements will be our Azure Entra ID, formerly Azure AD. This is a security resource for storing access accounts and role-based access control information. information about which resources and what permissions or actions the accounts registered in the account list of the Entra ID can perform across our subscription. We have specifically called out that we will be using service principals, which are essentially accounts that are used by services/resources and not human end users. Azure Infrastructure Alternative. In my designed Azure architecture, I've tried to allow it to be reusable and easier for me to manage when blowing away the SAP deployment. But you could make it much more simplistic for just a demonstration if you wish. Here, I have just one virtual network, one subnet, one resource group. The service principal we create in Entra ID will have permissions to manage any resources in the resource group. As you can imagine, the first time I wanted to run this code, I was a little worried that it might blow away my Ansible VM by accident. But it didn't. I still created a separate network and other items anyway, because I can now use this setup for other automation demonstrations. A better Azure infrastructure. The Azure architecture setup I have created is not great. It's very simplistic. It would not fit well in an enterprise scenario and is not great for security. Unfortunately, the Ansible Playbooks for SAP at the time of writing has some limitations. I've fed these back to the developers who are keen to improve it. So, if you see an issue, raise it. Here I have highlighted how I think some improvements could be made in a way that would not break the code dramatically or cause too much redevelopment. We've got a more hub and spoke friendly setup, segregating the resources into 3 different subscriptions. When you start to run enterprise systems in Azure, a single subscription can pose some limitations and some challenges around governance, which means it is best to try and segregate resources if you can. We also have better security with Azure Firewall, Bastion, NAT Gateway, and DNS in a controlled and restricted hub subscription. We can feel reasonably safe to let our Ansible Playbooks for SAP roam around and create resources in our Sandbox subscription and not need to worry too much. Azure policies provide governance, and these are flowed down from a special management group level above the subscriptions. These policies can prevent things like DNS private zones being created in a spoke subscription. We also make use of managed identities instead of service principals, which removes the need for us to embed credentials into our Ansible Playbook configuration files. It's a little bit safer. It's just a suggestion, and there are even more complex architectures out there, but generally most enterprises follow this hub and spoke model to some degree, and for good reasons. As mentioned, Ansible Playbooks for SAP will not work with this architecture because it needs resources like the virtual network and DNS private zone to exist in the same resource group as the target VM will be built in. Also note that one large limitation is that Ansible Playbooks for SAP does not deploy resources following SAP's flexible adaptive computing design architecture. The SAP system is installed against the virtual machine hostname. Building our Azure infrastructure. We've been through the Azure architecture, and in places I've called out resources that we will pre-deploy. Our deployment approach is as follows. We will pre-deploy everything that is not green. An Azure subscription with credit card. I'm using a 30-day free trial with $200 USD of credit, but it still needs a credit card or a way of billing you at the end of the 30 days. We pre-deploy the resources around our Ansible VM. We deploy the Ansible VM, and it will be called LNX Ansible 01. We pre-deploy the networking aspects of our SAP VM. We pre-deploy the Entra ID service principal account and assign permissions to create objects in the target resource group. The items in green are deployed by Ansible Playbooks for SAP because I have chosen to use the pure Ansible deployment mode, which cannot pre-deploy the other infrastructure dependencies. So it will deploy a new virtual machine, which we are going to call LSBX NWASC01. Plus, the playbooks will create a new DNS entry for the virtual machine once the network interface card has been deployed. Deploying Ansible. After we have deployed our prerequisite Azure infrastructure, we need to set up our Ansible system. The deployment of a basic virtual machine in Azure will only install the selected operating system on it. There are specific options from the Azure Marketplace, but these usually cost a small amount of money for the privilege of having an operating system plus some other software already bundled. After our deployment of our Ansible virtual machine, we will need to log on and download and install the Ansible software and its prerequisites. Ansible runs on Python, a programming language. The documentation of the Ansible Playbooks for SAP has a list of requirements, which includes Python prerequisites, including plugins and libraries, platform-specific SDKs, prerequisites to be able to call Azure or AWS or GCP, prerequisite Ansible collections, and some are included in a requirements YAML file for each specific scenario. I will show where this is later. An SAP user account for downloading our SAP installation media from the SAP website. Without this, you cannot access any installation media, and therefore, of course, you will need an SAP license. We will deploy all of the above into a segregated Python environment known as a virtual environment, and this will be located under the home directory of our Ansible Linux user account. Using a Python virtual environment allows us to patch the operating system and the base Python environment that comes with it without causing disruption to our segregated Python environment. Executing Ansible. If we imagine that we have now deployed all of our prerequisite Azure infrastructure, we've built a new Ubuntu Linux virtual machine, and on that we have deployed Ansible, and finally we have deployed Ansible Playbooks for SAP. How will we actually execute our playbook scenario? We talked at the beginning about what I'm calling execution methods for Ansible Playbooks for SAP. The first method is via Azure DevOps. In this method, we have our code being edited on our local PC using VS Code or some other IDE. The code is pushed and stored in our DevOps code repository. We use a self-hosted DevOps agent installed on our Ansible VM to pull down the code and execute it. The next method is to use a Microsoft managed DevOps agent which pulls down the code and executes it. We don't need to set up an environment for the Ansible code to execute in. But we still need to create a Bastion host for connectivity inside the virtual network from the agent. Another method is to install Windows Subsystem for Linux onto our PC and set up Ansible inside of it. Similar to running a small Linux virtual machine on our local PC, which is an alternative option, this removes some capabilities such as continuous integration and continuous development, or CI/CD, in favour of a much simpler setup. A final method is to set up Ansible on a hosted VM, which will also act as our Bastion host and also put our code directly onto that VM. Our local PC only needs to run an SSH client. There are a lot of sacrifices with this setup, and it's not something I would recommend as an architecture, but for the purposes of the demonstration, it makes it crystal clear where everything is and where it is being executed. This is the method that I will use for the purposes of this demonstration. Order of deployment. This is the order in which we will perform our work. Steps 1 to 13 we will cover in part 1 of this video. Steps 14 and 15 will be in part 2. Step 1. Create shared virtual network, vNet. In the resource search box, we search for virtual networks. Click Create. Our existing subscription is selected. We click to create a new resource group to hold our new virtual network and bind it to the UK South region. This will be our RG shared UKS01 resource group. We provide a new virtual network name and set the region to be UK South. Clicking Next, we can browse some additional security features, but we don't specifically need these for the demonstration. Click Next again. Step 2. Create shared subnet. Here we can see that the virtual network size is /16 and it gives us 65536 network addresses. We don't need that many, so we reduce it to /24. Then we ensure that the subnet size is also /24 because it can't be bigger than the virtual network size. Give the subnet a name other than default, which can be confusing if you have multiple subnets in different virtual networks all called default. Step 3. Create NAT gateway. Scroll down to NAT gateway and create a new one called NGW SNet shared UKS01. It will need a new public IP address to be able to provide outbound internet for the subnet. Step 4. Create subnet NSG. Create a new network security group called NSG SNet shared UKS01. Save the subnet changes and click Next. Here you can define tags to help identify resources, especially useful for billing purposes. We don't need to add any for our demo, so click Next to start the validation of the values we have entered. We click Create to start deployment. Step 5. Create Ansible VM. We're ready to create our new Ansible virtual machine. In the resource search box we search for virtual machines, select Create and select Azure Virtual Machine. Create a new resource group to hold our virtual machine. Set the virtual machine name to be LNX Ansible 01. The region should be UK South. We don't want to pay extra for using availability zones because we don't need high availability in this scenario. At this point, it's important to select Ubuntu 22.04 also. Don't mistakenly select 20.04, it must be 22 because 22.04 includes the required Python version already. Notice that it says free services eligible, which means we can deploy it on our free trial subscription. The VM size of standard B1S is already selected. If it's not, find it and select it. It's better security to use SSH public key for authentication into the VM, but for this demo, I want to use a username and password. We need port 22 exposed to the internet. Click Next. We can change the disk type on which the operating system is installed. Premium SSD is overkill for this VM, so I will change it to standard hard disk. If I was going to add an additional data disk, I would add it here in this screen. Click Next. This new VM will be connected to the virtual network we have already created. Notice that you can create a new virtual network here also, but it will create it in the same resource group as the VM itself. We automatically get a public IP address assigned to the VM, which is good. We need it on this VM to allow us to connect in over the internet. It's possible to create an NSG on the VM itself as well as the NSG on the subnet. We skip down to tick the delete public IP and NIC when the VM is deleted, and this just helps when cleaning up. Click Next. We will not select any of these options. Click Next. I like to disable boot diagnostics because it will create a new storage account for storing boot logs, and that costs money. If we have any problems, we can choose to come back and tick this at a later point. Scroll down and select Next. Click Review and Create. Validation is successful. Click Create. Deployment completed. We've now completed the deployment of our Azure infrastructure to support our Ansible virtual machine. We can move on to creating the infrastructure to support our Sandbox spoke, into which Ansible Playbooks for SAP will deploy on our new virtual machine. Step 6. Create Sandbox vNet. We need to create a new Sandbox spoke with its own virtual network. In the resources search box, we search again for virtual networks. The same steps we used when we created the shared services virtual network. Click Create. Our existing subscription is selected. We click to create a new resource group to hold our new virtual network and bind it to the UK South region. This will be our RG-SBX UKS01 resource group. We provide a new virtual network name and set the region to be UK South. Clicking Next, we scroll past the additional security features. Click Next again. Step 7. Create Sandbox subnet. The vNet default size is /16, so again we reduce it to /24. Before we go any further with the subnet, we need to change the network address range. We've already got 10.000 range, and we cannot duplicate this. See the warning at the bottom here. So we change the address to 10.0.1.0. We edit the subnet and give it a name other than default. Then we ensure that the subnet has the same starting address and set it to /24. Step 8. Create Sandbox NAT Gateway. Scroll down to NAT Gateway and create a new one called NGWSnet SBX UKS01. It will need a new public IP address to be able to provide outbound internet for the subnet. Step 9. Create Sandbox Subnet NSG. Create a new network security group called NSG SNet SBX UKS01. Save the subnet changes. Click Next. Click Next to start the validation of the values that we've entered. We click Create to start deployment. Our deployment succeeds. Step 10. Peer vNets. In this step, we allow our shared services virtual network to communicate with our Sandbox virtual network. The peering process could be between two different subscriptions, but we only have one. In the resource search box, we search again for virtual networks and open our shared network. On the left blade, we scroll down to Peerings and click Add. We need to give the peering a name. I'm using the convention of peer-source-target so that I can reverse operation. I can use peer-target-source. We then select our Sandbox virtual network as the peer and click Add. Once the peering is complete, click Refresh and it will say Connected. Finally, we select the peer virtual network to see its peerings and we see it has an equivalent but reverse peer connected now. Step 11. Create private DNS zone. We need a private DNS zone for the Ansible Playbooks to store the target virtual machine host IP address against the hostname. In the resource search box, we search for private DNS. Click Create. We must create this in the same Sandbox resource group as the Sandbox virtual network. We give it a name which corresponds to the DNS name we will be using. This will be the FQDN of our internal services. When Ansible Playbooks for SAP deploys the new VM, this will be the FQDN used for the VM and also for the SAP system. We click Next and then Review and Create to start deployment. After deployment, go to the new DNS private zone resource. We will now link this DNS to our virtual networks. On the blade, select Virtual Network Links and click Add. Give the link a name. This one is for the shared vNet. Select the shared vNet from the drop-down and click OK. While that's being created, we can also link the Sandbox vNet. Note that we could select the auto registration option on the link creation screens, but in the version 1.02 of the Ansible Playbooks for SAP, it will still try to register the IP address anyway and will fail if one is already there. Now we have both our links, I'm going to add an entry into the DNS for our Ansible virtual machine. I'm not 100% certain if the SSH public key trust that gets set up by Ansible Playbooks for SAP needs to use the hostname or the IP address. So I'm just going to add it here anyway into DNS. Step 12. Create Service Principal. We discussed before that the Service Principal is a kind of service account used by a system to access a resource in Azure. In our setup, Ansible Playbooks for SAP needs a Service Principal account to authenticate to Azure to call the APIs to create a new virtual machine. It will also do some other information, lookups, and other actions against things like DNS. We could be very specific if we wanted to know all the exact permissions it's going to need. This is best practice really, giving only the required permissions to perform the tasks. However, service principals are no longer the recommended method by Microsoft. So I feel that Ansible Playbooks for SAP developers may already be looking into adopting system-managed identities instead. In the meantime, we need to create this service principal in our Entra ID. In the resource search box, we search for Entra ID. In the blade on the left, we select App Registrations. Click New Registration. Set the name to be Ansible, so you know what this is. Click Register. On the left, select Certificates and Secrets. Click New Client Secret. Provide a name for this secret. A service principal can have multiple secrets. I will extend the expiry and click Add. Very important, we need to make a copy of the value output. I put this into my Windows Notepad temporarily. If you don't copy this here, then you will need to delete and recreate the secret and remember to copy it. Click back onto the Overview screen and also make a note of the application ID, also known as the client ID. Add this to your Notepad, but don't mix up the two items of data. You see that the client ID is a GUID string, whereas the secret is just a jumbled string of characters. Also copy the tenant ID to your notepad and label it so you know the difference between this and the client ID. We're going to assign some permissions to this new service principal. In the resource search box, we search for subscriptions and open our subscription. On the right, we copy the subscription ID and add this to our notepad and label it. In the Access Control IAM blade, we go to Role Assignments. Click Add, then Role Assignment. Then select Privileged Administrator Roles and select Contributor from the list. Click Select Members and search for Ansible, which is our app registration name. Select Ansible and click Select. Click Review and Assign, then click Review and Assign again. Our service principal is now created and has the contributor role at our subscription level. We could have instead applied the contributor role at our resource group level using the same steps, but in the IAM panel of the resource group blade. This would have been a better idea, but it was late and this was not the first attempt at recording some of this. Step 13. Expose SSH port. To be able to connect to our Ansible virtual machine, we gave it a public IP address. However, we would still not be able to connect at this point because the network security group of the subnet is blocking access to port 22 from the internet. Let's open it up. In the resource search box, we search for Network Security Group and open our shared subnet NSG. On the blade, select Inbound Security Rules. Click Add. Change the source to be My IP address. This will restrict the rule to only allow our internet IP address to access the port 22. Note that if our computer's internet IP address was to change, then we would need to come back into here and change this. You simply click the drop down away and then click it back to My IP address again. We set the service to be the SSH port, which adds a TCP port of 22 to the allow list. If we wanted to be implicitly prescriptive, it would be better to add the IP address of our Ansible VM into the destination field. This would make sure that this rule is only for the Ansible VM. We click Add. The Ansible virtual machine doesn't have its own dedicated NSG. It uses the one on the subnet. We can check by going into the Ansible VM and checking on the network settings blade. We see that the inbound rule is still missing port 22 here. Let's scroll up and just click refresh. Aha! There it is. We should now be able to make a connection from the local PC I'm using here to the new Ansible VM in Azure. Open up Putty on your computer, and for those that don't have Putty, the link is in the description down below. It doesn't look like a particularly professional website, but this is actually the source website. You can use the portable version of Putty, which is just the executable file. It's here, and you'll want either the 32-bit or 64-bit versions, depending on your version of Windows. Not sure on your version of Windows? Okay, well you can press the Windows key plus R, then enter Command/K, systeminfo, find string, system.type. If your output says x64 based PC, then you can safely use either the 32-bit or the 64-bit versions of Putty. If you have a 32-bit PC, then you will only be able to run the 32-bit version of Putty. If you're not sure either way, or you can't be bothered with the command thing, just download the 32-bit version. You can't go wrong. With Putty running, enter the public IP address of the Ansible virtual machine and click Open. If you forgot the public IP address, we saw it much earlier in the network settings blade of the Ansible virtual machine. It's here. We log into our Ansible VM using our Ansible username and password that we set when we created the virtual machine. You do remember that password? The virtual machine will be billed to your free tier credits if you are following along, so you will want to shut that down if you have it running at some point later today. That is done on the virtual machine overview page. You just click stop. This will shut down the OS and deallocate the virtual machine. It prevents it from being billed. To start it up again, you just click start, and after about 60 seconds you should be able to connect via SSH. Remember that if your computer's IP address changes, you may need to adjust that NSG to allow your connection through. That concludes our first part. In part 2, we run through the setup of Ansible on the Ansible virtual machine and we execute Ansible Playbooks for SAP. Don't worry if you've got a 30-day trial period, part 2 will be out shortly. Remember to subscribe if you've not already done so. This way the powers that control YouTube will let you know when part 2 is released. As always, reference links are in the description down below. Drop me a comment, give the video a thumbs up, and most importantly subscribe to the channel. Thanks for watching. Bye bye.